For centuries, we looked up at the night sky and only saw members of our own solar family. But recently, we've had not one, not two, but three confirmed interstellar guests drop by for a visit. I'm talking about the mysterious Oumuamua, the classic comet Borisov, and the newly designated Atlas. Each of these objects has a unique story to tell, a different set of clues about the distant star systems they came from. Today, we're putting them side by side for a cold comparison. What makes them different? What do they have in common? And most importantly, what can they teach us about the universe beyond our doorstep? We'll look at their discovery, their strange shapes and compositions, and their incredible journeys through the void. So, buckle up, because we're about to chase some comets and unravel the secrets of these interstellar wanderers. Let us start with the one that kicked off this whole new era of astronomy, 1I Oumuamua. The name itself is beautiful, a Hawaiian word meaning a messenger from afar arriving first, and what a messenger it was. Discovered in October 2017 by the Pan-STARRS telescope in Hawaii, Oumuamua immediately threw astronomers for a loop. Why? Because it looked and acted like nothing we'd ever seen before. First, let's talk about its trajectory. It came screaming into our solar system from the direction of the star Vega, moving at a blistering speed of about 26 kilometers per second relative to the Sun. Its path was a sharp hyperbola, a clear giveaway that it wasn't gravitationally bound to our Sun. It was just passing through. As it swung around the Sun and headed back out into interstellar space, scientists scrambled to observe it. But here's where it gets really weird. Oumuamua was small, estimated to be only a few hundred meters long, and its shape was bizarre. Based on the way its brightness fluctuated, astronomers concluded it was highly elongated, maybe 10 times as long as it was wide. Imagine a cigar or a pancake tumbling through space. We've never seen an asteroid or comet in our own solar system with such an extreme shape. Then there was its behavior. As it moved away from the Sun, it accelerated slightly, a push that couldn't be explained by the Sun's gravity alone. With comets, this is normal. As they heat up, ice turns to gas and jets out, acting like tiny rocket engines. This process is called outgassing. But here's the kicker. Astronomers looked very, very closely, and they couldn't detect any of the usual signs of outgassing. No dusty coma, no tail, nothing. It was just this dark, reddish, inert-looking object that was mysteriously pushing itself along. This non-gravitational acceleration without a visible coma is the central mystery of Oumuamua, leading to all sorts of speculation, from a unique type of comet made of hydrogen ice to, yes, even the idea of an alien artifact. It remains a fascinating puzzle. 2 years after Oumuamua's fleeting visit, a new interstellar guest arrived, and it was a completely different story. Meet 2I Borisov, discovered in August 2019 by an amateur astronomer, Gennady Borisov, using his own custom-built telescope. Now, that's a discovery story. Unlike the mysterious Oumuamua, Borisov felt ... familiar, almost comforting to astronomers. From the moment it was spotted, Borisov looked and acted just like a classic long-period comet from our own solar system's Oort cloud. It had a big, beautiful, dusty, coma-fuzzy atmosphere of gas and dust and a distinct tail. When astronomers pointed their telescopes at it, they saw exactly what they expected to see from a comet. A cocktail of familiar molecules like water and carbon monoxide. It was actively outgassing as it approached our sun, and its acceleration was perfectly explained by this process. No mystery there. Borisov was also much larger than Oumuamua, with its nucleus estimated to be several kilometers in diameter. Its composition seemed pretty standard, suggesting that the building blocks of comets in its home star system are remarkably similar to our own. This was a huge discovery in itself. It implies that the chemistry needed to form planetary systems might be quite universal across the galaxy. So, while Oumuamua was the weird, mysterious stranger that left us with more questions than answers, Borisov was like a visiting cousin from a distant land who turns out to be surprisingly similar to us. It showed that normal comets, just like the ones we know and love, are likely drifting between the stars all the time. Borisov provided a crucial baseline, a control group for studying interstellar objects. It proved that not every visitor from deep space has to be a cosmic enigma. And that brings us to our third and most recent interstellar visitor, 3I Atlas. This object has a bit of a tricky history. It was first spotted back in 2021 by the Atlas Survey, the Asteroid Terrestrial Impact Last Alert System in Hawaii. But at the time, we didn't have enough data to confirm its interstellar origin. It was just a faint, fuzzy blob. It wasn't until early 2024 that astronomers, after reanalyzing its path with more observations, officially designated it as our third interstellar object. So, what is 3I Atlas like? Well, it seems to be another classic comet, much like Borisov. It was observed to have a coma and a tail, meaning it was actively releasing gas and dust. This outgassing, just like with Borisov, fully explains its trajectory and its non-gravitational acceleration. No mystery push needed here. Its composition also appears to be broadly similar to the comets from our own solar system. One key difference with 3I-ATLAS, however, is its journey. It appears to have been ejected from its home star system a very long time ago and has been wandering the galaxy for ages. And when it encountered our sun, it didn't get a very warm welcome. As it got closer to the sun, the heat caused it to break apart and disintegrate. We see this happen with our own comets. Sometimes they are fragile, dirty snowballs. After all, the fact that an interstellar comet did the same thing provides yet another piece of evidence that cometary physics is pretty consistent, whether here or in another star system. So, 3I-ATLAS solidifies the Borisov model. It reinforces the idea that most interstellar objects are probably just good old-fashioned comets or asteroids, kicked out of their home systems by gravitational interactions. It makes Oumuamua look even more like the odd one out. So, let's put it all together. What have we learned from this trio of travelers? We have a fascinating spectrum. On one end, we have the ultimate enigma, Oumuamua, small, strangely shaped, reddish, and accelerating without a visible cause. It defies easy categorization and keeps the door open for wilder, more exotic possibilities. It's the puzzle that keeps astronomers up at night. In the middle and on the other end, we have Borisov and Atlas. They are our normal interstellar comets. They look, act, and are composed of materials very similar to the comets born in our own solar system. They are incredibly valuable because they suggest that the planetary formation processes across the galaxy might not be so different from our own. They provide a context, a baseline that makes Oumuamua's weirdness stand out even more. The discovery of these three objects in just a few years is revolutionary. It's like we've spent our whole lives on a remote island, and suddenly 3 different ships from unknown lands have washed ashore. One is a familiar-looking sailboat, Borisov. Another is a similar but broken raft, Atlas, and the third is a sleek, strange vessel with no sails or oars that somehow propelled itself here, Oumuamua. The future is incredibly exciting. With new, more powerful telescopes like the Vera C. Rubin Observatory coming online soon, we expect to find many more of these interstellar visitors, perhaps dozens per year. Each new discovery will be another piece of the puzzle, helping us understand the diversity of objects out there. Will we find more Oumuamuas, or will they all be Borisov-like comets? Finding another object like Oumuamua would suggest they re a common class of object we just don't understand yet. But if we only find more normal comets, it will make Oumuamua an even more profound and singular mystery. These cold comparisons aren't just about cataloguing curiosities. They are about piecing together the story of our galaxy, one visitor at a time. They are samples from other star systems, delivered right to our cosmic doorstep, giving us clues about how planets and life might form elsewhere in the universe. What do you think is the real story behind Oumuamua? A nitrogen iceberg, a hydrogen comet, or something else entirely? Let me know your theories in the comments below. It's a cosmic mystery, and every idea is worth exploring. Thank you so much for joining me on this interstellar investigation. If you enjoyed this journey through the cosmos, please give this video a thumbs up. It really helps the channel grow. And for more deep dives into the mysteries of space, don't forget to hit that subscribe button and ring the notification bell. Until next time, keep looking up.